In this video, we'll discuss the perimeter of polygons. Now, the perimeter is the distance around the edge of the shape, and we determine it by adding all the lengths together. For example, say that I have this concave hexagon, A, B, C, D, E, F. I can add all the 6 lengths together, and that will determine the perimeter to be 23 inches. Now, if any of those were of a different unit, I'd have to convert it first and then add all 6 together. Now here's another unique case you can see. Here is a pentagon where we are missing the length of JK. So we need to determine JK before we can determine the perimeter. Now to do that, since I have all these right angles, I recognize that I could draw an extra segment here, and the length of this entire side has to be equivalent to the length of GH. So since GH is 26 feet, I know that little segment would have to be 6 feet, because 20 feet plus 6 feet has to equal 26 feet. The same will be true then when I think about HK. I've got this vertical side that would be approximately, that should be 11 feet, which means that the last portion of that would have to be the remainder of the 19 feet, which is 8 feet. Now that I have a triangle, I should recognize, because of these 3 90-degree angles, that this will also be a 90-degree angle, forming a right triangle. Therefore, we can use the Pythagorean theorem to find the length of JK. So 6 feet squared plus 8 feet squared will equal JK squared. That will give me 36 square feet plus 64 square feet to equal JK squared. I'm going to add those two lengths together because they have the same unit, square feet, and then I'm going to take the square root of both sides to get JK back to a single unit. And when I take the square root of 100, that is 10, and the square root of square feet is just feet. So JK has a length of 10 feet. Now I can look at the lengths of each of the sides and add them together. So I have the 11 feet, the 20 feet, the 10 feet, the 19 feet, and the 26 feet to get an entire length of 86 feet for the perimeter. Now, people often wonder, is there a relationship between the area and the perimeter? However, if we know the area of a shape, that doesn't necessarily mean we know the perimeter of the shape. So consider we know that we have a quadrilateral, and we want to say something about the perimeter if we know the area of the quadrilateral is 16 square centimeters. It doesn't tell us very much, and let's look at 3 examples to show us why. All 3 of these shapes are quadrilaterals, and all 3 have an area of 16 square meters. I know the third one looks a little bit different, but we could split this into a triangle, and a rectangle, and find that the area is 16 square centimeters. But in the first one, this is a 4x4 square. It has the area of 16 square centimeters, but the perimeter is 16 centimeters. When I look at my middle rectangle, this is a 2 centimeter by 8 centimeter rectangle. Its area is 16 square centimeters, but its perimeter is 20 centimeters. In this third one, again, this is a general quadrilateral. It has an area of 16 square centimeters, but the perimeter is approximately 17 and 1500 centimeters. Now, what if we can specify, we need something more than just a general quadrilateral. We need to know that it is a very specific shape. Again, we don't necessarily have the ability to say what the perimeter will be based on the specific shape. So what if we stated that we want the perimeter of a rectangle and we know the area is 16 square centimeters? Well, if you think about the first 2 examples, we don't know much at all, because a square and the 2x8 rectangle are both rectangles. And here's a third one. This is a 1x16 rectangle. These are all rectangles that have area of 16 square centimeters. But again, the perimeter of the square was 16 centimeters. The perimeter of the 2x8 was 20 centimeters. And the perimeter of this 1x16 would be 34 centimeters. So just knowing the specific shape also can't help us. So we have to be very careful about some of how we compare area and perimeter, because just knowing one doesn't necessarily mean we know how to determine the other.